Now I said the budget line of the consumer requires that the amount of money spent on the two goods is no more than the total amount the consumer has to spend. That is what budget constraint means. Now, we also talked about the budget line, and I said that the budget line requires that the total expenditure on the two goods should be equal to the income that the consumer has. So the total expenditure on the two goods or the set of bundles that cost exactly M or the consumer income is what we call the budget line. Then we discussed how you can draw the budget line on a Cartesian plane. And of course, we discussed about the slope of the budget line, which is simply the ratio of the prices of the two commodities. Then we said that the slope of the budget line simply represents the opportunity cost of consuming one good or the second one, which means that in order to consume more goods of good one has to give up some consumption of good two. Then I said that we can present consumer preferences on an indifference curve. And they said that consumer preferences is a complete list of goods and services that are involved in the choice problem faced by the consumer. So we can describe the consumer preferences using the indifference curve. But before we described the consumer preferences using the indifference curve, we also mentioned some assumptions about consumer preferences. So I talked about completeness. I also mentioned reflexive, and then finally transitivity as the assumptions about consumer preferences. Then these preferences, I said that we can describe them using the indifference curves. And we also talked about different shapes of the indifference curve. So we talked for perfect substitutes, where the indifference curve is parallel lines. So we also mentioned about the perfect complements, which have L-shaped indifference curves. We also talked about bad goods. So the bad goods have difference curves sloping upwards from left to right, and which are parallel to each other. And we talked about the neutral goods, which have indifference curves that are perpendicular and parallel to each other. Then finally, we talked about the imperfect substitutes, so which have convex indifference curves. The indifference curves for perfect substitutes are convex to the origin. That is because of the diminishing rate of marginal substitution. Now today, we want to look at the marginal rate of substitution. And this marginal rate of substitution is the slope of the indifference curve. So the slope of the indifference curve is what we refer to as the marginal rate of substitution. So it measures the rate at which the consumer is just willing to substitute one good for the other. So if the consumer is consuming two goods, that is X1 and X2, and the consumer gives up certain units of X1 in order to obtain more units of X2, or the consumer can also give up some units of X2 in order to get more units of X1. Now, the change in good 2 over the change in good 1 is what we refer to as the marginal rate of substitution. So which simply measures the rate at which you can exchange one good for the other. So the rate at which you can exchange commodity 1 for commodity 2 is what we refer to as the marginal rate of substitution, which is indicated by E in that expression. So if you want to get the change in commodity 2, so this one should be equal to the slope of the indifference curve times the change in commodity 1. Or the change in commodity 1 should be equal to the change in commodity 2 divided by the slope of the indifference curve, which is 2, sorry, which is E. Now, if we have the indifference curves for the two commodities, that is X1 and X2, and then we have the budget line and we have indifference curves. I've said the slope of the indifference curve simply shows that the change or the rate at which the consumer can exchange one commodity for the other. So if you compute, for example, the slope of the indifference curve that is illustrated there. So the slope of the indifference curve is given as the change in y over the change in x, so which should be equal to E. So we can use E to show the slope of that indifference curve. Now the consumer can consume a bundle that is made up of X1 and X2. Now where that slope, sorry, the indifference curve is attached, or the budget line is attached to the indifference curve, that is where the consumer will consume. And we will have a combination of X1 and X2. Now, if you move up and to the left from X1, X2, so this involves exchanging good 1 for good 2. And moving down to the right involves exchanging good 2 for good 1. Now, in either movement, the exchange rate is E. So whether you move upwards or downwards, the slope simply remains the same, which is E. Now, in simple terms, the exchange always involves giving up one good in exchange for another. And the exchange rate in that case corresponds to the slope at E. Now, the point of tangency between the budget line and the indifference curve is referred to as the consumer equilibrium. So if you look at the diagram well, there is a point of tangency between the second indifference curve and patched line. So that point of tangency, where the patched line is attaching to the indifference curve, that is where the consumer is in equilibrium. Now, we can look at the behavior of the marginal rate of substitution. So we have discussed the various shapes of indifference curves. So we have discussed the indifference curves for perfect substitutes. So for imperfect substitutes, for complementary goods, and others. Now, for perfect substitutes, the indifference curves are characterized by the fact that the marginal rate of substitution is constant at -1. It is constant at -1. So what does that mean? For perfect substitutes, so for perfect substitute, we said they have parallel indifference curves. And the marginal rate of technical substitutions, of substitution, is simply constant. It doesn't change. So in the case of the neutral goods, now the marginal rate of substitution is infinite everywhere. So you can refer that to the shape of the indifference curve that we discussed earlier. Now, the preference for perfect complements are characterized by the fact that the marginal rate of substitution is either infinite and nothing in between. It's either zero or infinite, nothing between. So perfect complements, they have L-shaped indifference curves. So if you go back and look at the shapes of the indifference curves for perfect complements, so it is an L-shaped difference curve. But the assumption of monotonicity implies that the indifference curves have a negative slope. So the marginal rate of substitution is always involving reducing the consumption of one good in order to get more of another good for monotonic preferences. So for monotonic preferences, we are talking about imperfect substitutes. So if you look at the indifference curve for imperfect substitutes, so they are downward sloping and it is a curve. So which means the marginal rate of substitution declines or reduces downwards from left to the right. So for convex indifference curves, which are for imperfect substitutes, the marginal rate of substitution decreases as more of good one is consumed. Thus, the indifference curve exhibits a diminishing marginal rate of substitution. So as you move from left to right downwards, the convex difference curve, marginal rate of substitution diminishes or reduces. That means you'll need less of good one to get more of, or you'll need less of good two to get more of good one. Now, what a utility function. A utility function is simply a way of assigning a number every possible consumption bundle, such that more preferred bundles get assigned large numbers than less preferred bundles. Now, at the beginning of the study to the consumer behavior, so we said that you can study the consumer behavior using two approaches. So the first approach is the ordinal approach, which simply assumes that you can measure utility using units of measurement called utils. Now the other study or approach simply through what we refer to as the cardinal approach. And the cardinal approach simply assumes that you cannot measure utility, but you can only rank the preferences or the satisfaction. And the cardinal approach normally uses what? The difference curves to analyze the consumer behavior. Now, using the ordinal approach, where we assume that we can measure utility using units of measurement called utils, so we can come up with the utility functions. So a utility function is how we can label the indifference curves. So the indifference curves can also be represented in form of utility functions. Now, just like the different shapes that we have for indifference curves, we also have utility functions that are specific to those indifference curves that we discussed earlier. So for example, the utility function for perfect substitute goods. Now for perfect substitute goods, the utility function is represented in a linear utility function of the form that is indicated. It is simply a linear function of the two goods. So if we were to frame the utility function for perfect substitutes, we will have a linear utility function. So you know linear equations. If you are told to draw lines for linear equations, you will have straight lines that are parallel. That means that the utility function for perfect substitutes, they are simply linear. So if we have a utility function, for example, which is a function of would 1 and would 2, is illustrated at alpha x1 plus beta x2. You look at that function or equation, it's simply a linear equation. And if you draw them as a Cartesian plane, you will have a straight line. So alpha and beta are greater than 0, and they measure the value of wood 1 and 2 to the consumer. So by plotting all the points for x1 and x2 such that the utility function equals a constant, so you'll yield a linear indifference curve with a slope of alpha over. If you draw that utility function, you'll have indifference curve of this nature, which we said are linear for perfect substitutes. We also have a utility function for complementary goods. We said that these are goods that are used together. complementary goods are goods that are consumed together. So the preferences for complementary goods take a utility function of the form is indicated here. So it is a minimization problem. So you minimize good 1 and good 2. So the utility function is simply a minimization problem, which is illustrated by a function that you can see on the slide. Now, the minimization problem simply shows that the indifference curves are L-shaped. So you can minimize x1 and x2. Now the alpha and the beta are positive numbers that indicate the proportion in which the goods are consumed. So the indifference curve for such a function is L-shaped, as you can see. So x1 and x2 in that case, they are perfect complements. Now for imperfect substitutes, we have a utility function that is described by that equation, and it takes a utility function that is known as the Cope-Douglas utility function. So that kind of utility function is referred to as the Cope-Douglas utility function. So it yields a constant monotonic indifference curve and are said to be well behaved. So a monotonic transformation of the Cope-Douglas utility function that is indicated above will be represented by convex indifference curves. So the indifference curves for Cope-Douglas utility function is indicated in the convex indifference curves. So we have difference curves 1 up to 4. So we said that the lower indifference curves shows lower utility level, while the upper indifference curves shows high level of what? Utility. Now, those are the utility functions that we can have for different goods that we have discussed for perfect substitutes, complementary goods, and for perfect substitutes.
So we can't hear you.
Oh, you can hear me?
Now we can.
Oh, okay. Now from that presentation, you can now raise some questions and clarification. You can raise questions and clarifications. So you can unmute your mic and ask a question. Brian, Michael, and Stephen, I hope you can hear me. Now the floor is open for questions, comments, and suggestions. Brian?
It's not really a question. It's a request.
Yes.
Since last semester's exams are coming,
Yeah.
could we? Okay, we would like to. We were requesting that you send us a few notes.
A few notes for
All the notes
which for which unit?
for mathematics, for economics, and also macroeconomics.
Oh, I thought I forwarded the remaining part of the notes that we didn't discuss.
Yes, the remaining. Yes, the remaining part. But also, if you could just send us the entire thing, so that
Uh-huh.
so that we can also expand the knowledge base.
Okay. I'll check. I'll check from where we left so that I forward you the rest of the notes.
Okay.
Okay. Now, regarding what we have discussed and concerned, Michael, you can unmute your mic and speak. Okay, Stephen, you can ask a question. Michael, I can hear you. I hope the presentation is well.
It is.
Now, what I can suggest is that you need to go through these notes very carefully. I know this unit is very tricky, and you need to ensure that you understand every statement and every part that we cover. Now, you need to know that you are able to formulate the budget constraint. You need to know what is the difference between a budget constraint and a budget line. So you need to know the shapes of what? The different curves for perfect substitutes, for neutral goods, packed goods, and what? Perfect substitutes. Then you also need to know the utility functions of the various goods. So you need to know the utility function of the perfect substitutes. You need to know the utility function of perfect complements. You also need to know the utility function of the imperfect substitutes. But the next part that, of course, that is important that we will be required to look at is how to come up with the demand functions. So the demand functions will require some calculations. Now, since you have done mathematics, so of course, hope you will not have a problem in deriving the consumer demand functions, because in deriving the consumer demand functions, so we'll be required to have a utility maximization problem. So the utility maximization problem requires you to formulate budget constraint and also to have a utility function. So you will maximize the utility you have, that is the utility function subject to budget constraint. So the next step will be require deriving the consumer demand functions. That's why I've insisted that you need to know how to formulate the budget constraint, and also you need to understand how you can formulate the utility function. So once you have understood that, the next level will require you to maximize the utility that you have subject to the budget constraint. And of course, that will require us to formulate what we refer to as the Lagrangian multiplier. So we formulate the Lagrangian multiplier, and then using the differentiation and integration, so we'll be able to derive the consumer demand functions. But before that, it's important that you understand how to formulate the budget constraint and the utility functions. Those are the most important things in this part. Any other concern? Even
I'm good.
everything is okay.
Yes.
Michael Musioki,
So, sir, can I ask about the
about
boundary of mountain and the particle?
I can't hear you well. Michael, I can't hear you well.